So, question number 78 is on your screen. For the redox reaction, the correct coefficient of the reactants for the balance equation are. So, this question is come from your redox chapter of class 11 chemistry. Now, we are moving to the solution part. So, here they are given you the redox reaction and they asked about the coefficient, and always remember the n factor whatever we are obtaining here. If I am reverse this n factor, I am write it here in clear form, n factor reverse, you are obtain the coefficient. So, this is a kind of a, you can say it is a trick. There is a concept is there, but for understanding or too easy to solve this kind of question, please remember this trick. N factor if you reverse, you will obtain the coefficient. So, first of all we have to find out the n factor. Now, first before n factor you have to find out the oxidation state of manganese and this carbon. Okay. So, how it we found out? Here I am putting as x minus 8 is equal to minus 1. So, x is nothing but plus 7. I am changing this color. So, plus 7 is the oxidation state. Now, for this twice x minus 8 is equal to minus 2. So, twice x is equal to 6. So, x is equal to plus 3. Now, remember this plus 3 is for one carbon, not for two carbon. Please keep in mind, because here they already given 2, but whatever we are find it out here the plus 3, this plus 3 is for single carbon. So, plus 3 for one carbon, okay, for one carbon. Now, for this one it is plus 2, and for this x minus 4 is equal to 0. So, x is equal to plus 4. So, now I am going to rub this part. Now, if you see here plus 7 it go to plus 2, means the reduction process is happened. Now, in another one here plus 3 to plus 4 is happened, means the oxidation process take place. Now, how to find out the n factor? N factor is for this MnO4 minus plus 7 minus 2. So, what is 5? So, 5 is the n factor for MnO4 minus. Now, n factor for this another one n factor, that is plus 3, and I already said the plus 3 for one carbon. So, how many carbons is there? 2. So, 2 into 3 minus 4. So, it is coming as 2, and I already said if I reverse this one I will obtain the coefficient. So, the n factor ratio is 5 is to 2. So, what you get the coefficient ratio? You will get as 2 is to 5. So, you have for 2 and 5, 2 and 5. So, if you go to the option part, option number 3, if you see the 3, MnO4 is 2 and C2O4 is 5. So, option number 3 is the correct answer of that question. Next, we are moving to the another question. So, question number 79 is on the screen. So, which one of the following condition will favor maximum formation of the product in the reaction? Now, we are moving to the solution part. So, my dear students, this question is basically come from the thermodynamic chapter, which is given on your NCERT 11. Okay. And this is the application of Le-Chatelier's principle. And what Le-Chatelier's principle said, that low temperature and high pressure is always favored to give the maximum product. So, option number 1 is the correct answer of question number 79. Now, we are moving to the another question, that is question number 80. So, question number 80 is on the screen. The correction factor A to the ideal gas equation corresponded to. So, this question is basically related with your states of matter of class 11 chapter. So, now come to the solution part. This factor A is basically tells about the attractional force, that is attraction between the gas molecules. So, this concept is already given on your NCERT 11, that is states of matter. So, if you see among this, which one is density of the gas molecules? No. Electric field present? No. Volume of the gas? No. Your last option, that is force of attraction. See, attraction force. So, the option number 4 is the correct answer of question number 80. Now, we are moving to the another question, that is question number 81. So, question number 81 is on your screen. So, magnesium react with an element X to form an ionic compound if the ground state electronic configuration of X is 1s2, 2s2, 2p3. The simplest formula for this compound is. So, now we are moving to the solution part. So, if you see here, the magnesium is given. Okay. So, first left out this magnesium, first let us see this X. Okay. So, X is given as 1s2, 2s2, 2p, 2s2, 2p3. So, if they ask about the valency, so what is valency? This actually basically tells about the combining capacity. So, how to find it out? Because it is more than 4. So, if it is more than 4, so what we will do? We do 8 minus your outer one, that is 3, 4, 5, that is your ultimately as 8. So, X, the valency is 3. So, if you see magnesium, basically it is present as, if it is Lewisian, so it is become 2 plus. So, how, what is the formula we are obtaining here? Our formula is Mg2 x3. So, what is the answer? Answer number 1 is the correct option of question number 81. So, question number 82 is on your screen. Iron exhibit BCC structure at room temperature. Above 900 degrees Celsius, it transformed to FCC structure. The ratio of density of iron at room temperature to that at 900 degrees Celsius is, in the bracket they are mentioning as, assuming molar mass and your atomic radius of iron remain constant with temperature. So, now we are moving to the solution part. So, before start this solution, we should know these values, and these values we are already discussed in our theoretical part. Okay, for BCC, that is Z, that is the total lattice count, it will be end up with 2, and for FCC it will be 4, and the relationship between A and R, A equal to 4 R by root 3 and A equal to 2 root 2 R for FCC. Now, there is a formula for density, D equal to Zm by Na into A cube. So, this formula we are going to use it here, but they already mentioned into the question that your mass and your atomic radius is constant. So D is directly proportional because Na value is already constant. So D is directly proportional to Z and inversely proportional to A cube. Now D at 25 degrees Celsius, it will behave as BCC, and D at 900 degree Celsius, it will behave as your FCC. It is already mentioned in the question. So if you see Z by A cube for BCC and Z for A cube for FCC. Now just rearrange this term, that is Z for BCC and Z for your FCC into this A cube part will be go above, A cube for FCC and A cube for your BCC. So Z for BCC, what is the value? It will be 2, and what is the value for FCC? It will be 4 into A for FCC, it will be end up with 2 root 2 R, and for BCC it will be 4 R by root 3, and this part it will be go as cube form. Now this R and R it will be cancel it out, 2 4 it will be 2, and this 2 we can write as root 2 into root 2. So root 2 and root 2 will be cancel it out. So we are end up with 2 by 4 into root 3 by root 2 whole cube. Now if you see here this root 3, this 2 by 4 into this root 3 whole cube, we can write like this 3 root 3, and this root 2 we can write like this, right, 2 root 2, and 2 and 2 it will be cancel it out. So we are obtaining here 3 root 3 and your 4 root 2. So this is our answer. Okay. So now see the options whatever they are given. So if you see among 4 options 1, 3, 2 and 4, your option number 2, that is 3 root 3 and 4 root 2 is the correct answer of your question number 82. So now we are moving to the next question, that is question number 83. So question number 83 is on your screen. Consider the following species, that is Cn plus, Cn minus, NO and Cn, and they ask which one of these will have the highest bond order. So this question is come from the chemical bonding chapter of your class 11 NCERT. So now we are moving to the solution part. So if you see on the board, so this is the simple trick. Okay. So this is not the actual concept, these are the concept, but this is easy trick to solve. Okay. So if you see, if your total electron cloud is greater than 14, you have to follow this order. Okay. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz, pi 2px, pi 2py, pi star 2pz, pi star 2py, sigma 2pz. And when your electron count is less than your 40 or equal to 14, you follow this order. See here only one difference, the difference is here, that is why I am marked it here. Okay. See this part and your this part. If it is greater than 14, then this sigma part will be come forward, and if it is less than 14, it will be come later after this pi 2px and pi 2py. So the reason is different, reason is already given on your NCERT as well as in your theory. So this order you have to follow, and for bond order calculation you got bonding molecular orbital and anti-bonding molecular orbital. See, the star part is known as anti-bonding molecular orbitals, and where star is not given, those are the bonding molecular orbital. Now, let us see what are the compounds they are given and which are they follow. So, if you see from the options, option number 3, that is Cn minus. So, what is the total electron count? So, from this it is becoming as 6 plus 7 plus 1 and it is coming as 14. Okay. Now, when it is become total electron count is 14. So, what order we have to follow? We have to follow this order, means sigma 1s 2, sigma star 1s 2, sigma 2s 2, sigma star 2s 2. Then pi 2px and pi 2py. So, up to here see 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 2pz is coming as 2. See 2 plus 2 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, if you see the bond order, anti-bonding minus anti-bonding. So, if you see the bonding 2, 2 to 4, 5, 6, 7, 8, 9, 10. So, your bonding is 10 and anti-bonding 2 plus 2, that is 4 and divided by 2. So, it is coming as 3. And if you calculate the remaining elements also, you will find out the bond order. But if you calculate the Cn minus, the bond order will be more, that is 3, and remaining the elements whatever they are given, that Cn plus or whatever they are given mentioned into the options, those values are always or not always, these are for this question it is coming below than 3. So, they are asking where the maximum bond order you will find. So, the Cn minus will show you the highest bond order, that is bond order 3. So, question number 84 is on your screen. So, which one is a wrong statement? So, this question is very easy. Okay. So, let us move on to the solution part. So, it is very visible, the option number 2, because it does not obey the Hund's rule of maximum multiplicity. Okay. So, they ask about the wrong statement. Which one is the wrong statement? Option number 2 is the correct answer of question number 84. Now, we are moving to the next question, that is question number 85. So, question number 85 is on your screen. So, which oxide of nitrogen is not a common pollutant introduced into the atmosphere both due to natural and human activity? So, this concept or this question is come from the environmental chemistry part of your class 11 chapter, and is a factual thing. The first option, that is N2O5. N2O5 is the correct answer of this question. Now, we are moving to the another question, that is question number 86. So, question number 86 is on the screen. Hydrocarbon A reacts with bromine by substitution to form an alkyl bromide, which by Roots reaction is converted to gaseous hydrocarbon containing less than 4 carbon atom. A is. So, this question is very easy. So, just focus on the first part. Now, come to the solution. So, what they said? They said that alkyl bromide will form and reaction with bromine. So, alkyl bromide means it is CH3Br. So, for this definitely we require Br2 and H nu. This is the reactant. So, definitely my friend, this is CH3Br. So, nothing else, that is your CH4, that is alkene, sorry, that alkene, when alkene is react with Br2H nu, it gives CH3Br. So, no need to go to the further. If you concentrate on the first part, you will easily get the answer, that is answer number 4. So, option 4 is the correct answer of question number 86. See, it is very easy. So, do not worry about organic chemistry, the questions are very easy from the organic chemistry. So, now we are moving to the another question, that is question number 87. So, question number 87 is on the screen. The compound A on treatment with sodium gives B and with PCl5 gives C. B and C react together to give diether. A, B and C are in the order. So, now let us move on to the solution part. So, if you see that this question I simplified here, right. So, what happened? A, when treatment with sodium metal, it will give B, when A is react with PCl5, it will give C, and when B and C are combined, they will give diethyl ether. Now, see the option, if you see in the option, if you see the second option, it is not possible even. So, this option we can easily neglect it out. The first the first option is already negative for this reaction. So, this option number 2 we can neglect it out. Now, PCl5 means whatever C we are getting, it should definitely contain this Cl. Whatever is present, that I am not going to consider, just at the end or in the product you have to find it out Cl. Now, if you see the option number 1 C2H6, no, it is not possible, because I already said the C should contain that Cl. So, if I am saying this is A, this is B and this is our C, okay. Sorry. So, C, this is B, this is C. Now, C, Cl is having. So, okay, this may be the answer. Now, if you see the C option C2H5ONa, no, this is not our option, because I already said if C it's A react with PCl5, then definitely that element should having that Cl in their compound. So, this not possible. So, option number 3 again neglect it out. Now, option number 4 is possible. Now, if you see the A when react with sodium, then definitely whatever B we are getting, it should having this sodium at the end, means sodium salt or sodium something will form. So, sodium is also there. Okay. Now, see the options. So, B C2H6, no, it is not possible, because I already said the compound whichever we are taking, it should contain this sodium. So, B is not the option. So, we have left it out only one option, that is option number 4, and this is the correct answer of your question number 87. So, this is the easiest way to solve any organic questions. If you do not know any one of the reaction fully also, you can easily solve the question by neglecting the remaining options. See, again I am repeating here, A when react with sodium, is give B, means that B compound must have this sodium in it. So, see, if you see in the B option, there is a no sodium, only in option 4 is sodium. So, maybe the option 4 is correct. So, automatically you can neglect it out the remaining stuff. And if you see the C option also, PCl5 reacting, means the end it should be having Cl. So, if you see the in option 3, only 2 options, that is option number 1 and option number 4 having Cl, and this remaining 2 and 3 does not have Cl. So, option 2 and option 3 already neglected. So, just after everything is solved it out, we get only option 4 as the correct answer of this question number 87. So, now see the answer how it will come. See, now C2H5OH when it is react, it will give C2H5ONa. O minus Na plus, and when it react with PCl5 it gives C2H5Cl. Now, when this C2H5Cl plus C2H5O minus Na plus will react, it is a SN2 mechanism and you will obtained with diethyl ether. So, in exam if you do not know the whole reaction also, by neglecting or by eliminating the options you can easily solve this question. So, question number 88 on the screen. The compound C7H8 undergoes the following reactions. So, now we are moving to the solution part. So, before that you just see the options. In options they are mentioning toluene, 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 toluene. So, definitely this should be a toluene. Okay. Now, when this react with 3Cl2 by heating, you will get Cl, and after that when it is react with Br2Fe, it is nothing but this give you the electrophilic aromatic substitution reaction. So, what you got? You will get a, because this part is an electron withdrawing group CHCl2. Okay. So, again I am writing here, it is an electron withdrawing group. Okay. So, electron withdrawing group is a meta direction in nature. So, and this part will give you the electrophilic aromatic substitution, and where substitution taking place in the meta position. So, what you will get? CHCl2 bromine. Now, when it is react with ZnNaCl, so it is nothing but this is a reducing agent. So, what happened? This part will get reduced and you will get up this product. So, this is nothing but this is your C. Now, if you see which one is metabromotoluene is the correct option. Now, is it required to solve all the things? No, no need. If you know that this is an electron withdrawing group, just remove this part. So, if you know this is an electron withdrawing group, so definitely whatever oncoming element or compound is with, that should be attached in the meta position, means this position, this is ortho, this is meta and this is para. Now, in the options if you saw here, they are not mentioning any meta, ortho or something. So, this option will be neglected. Here they are mentioning as ortho bromo, no, this is not possible. Here they are mentioning as para, so this is also not possible. Only one option is left it out, that is your metabromotoluene. So, in this way you can easily solve these questions. Now, we are moving to the another question, this is question number 89. So, question number 89 is on the screen. Identify the major products P, Q and R in the following sequence of reactions. So, now we are moving to the solution part. So, this is the reaction they are giving. So, first let us see what will happen with this and AlCl3. Now, CH3, CH2, CH2, Cl, when it is react with AlCl3. I already mentioned AlCl3 is a Lewis acid and it is having this vacant orbitals. So, this one will be shifted here. So, what we will get? CH3, CH2, CH plus and AlCl3, Cl4 minus. Okay. Now, after that what will happen? This positive sign is not stable. So, now 1,2 hydride shift will take place. So, what we will get? CH3, CH and CH, here it will be coming as positive charge CH3, CH, CH3, Al, Cl4 minus and positive. So, no need to remember this whole complex, just remember this one, it is more than enough. So, this one is go to the further reaction. Now, after this one is go and react with this benzene. So, this benzene will attack with this position and you will get now. Are you remember what is this? This part we already discussed on our 2019 previous year paper. Okay. So, most of you can recognize this was nothing but this is your cumene. Okay. Now, see the options where cumene is there. See, this is not a cumene structure. So, option 1. So, this is nothing but this is your P. Okay. So, P is a cumene. So, this is not the product. See, this may be your product, this is not your product and this may be your product. Now, after cumene preparation, we know after cumene what is the end product we are getting? Where end product is CH3, C double bond O, CH3, that is ketone and a phenol. This already we are discussed and also it is very important, preparation of phenol from cumene. This one asked in 2019 also, in 2018 also. So, this part is very important. So, do not forget. So, this cumene after reactions of everything we are end up with these two product, okay, that is ketone and the phenol. So, now see where is the phenol and ketone is there. So, this is phenol, okay, it is possible, but see here whatever given they are secondary alcohol will not produce, here the ketone is produced. So, option number 4 is the correct answer of this question. Now, we are moving to the next question, that is the last question, question number 90. So, question number 90 is on your screen. So, which of the following compounds can form a Zwitter ion? So, this is a very simple question, direct question, and this come from the biomolecules part of your class 12 chapter. So, what is the answer? The answer is glycine. Glycine is the correct option of question number 19. Zwitter ion, how they look? This is NH3 plus CH and COO minus. Okay. This is the kind of a Zwitter ion where positive and negative charge is present. Okay. And the option is your option number 4 is the correct answer of question number 90. So, my dear students, today we are learned lots of chemistry, lots of chemical equations and see lots of periodic trends also and solving many as much questions. Okay. So, next class we are going to more digging into the chemistry and learn more number of concepts regarding chemistry. So, till then keep learning, keep revising. Thank you.